Howdy y'all. So today we're going to go over measures of central tendency and when to use them with regarding to what variable. Fair warning, this is going to be a less scripted video because I'm simply going to go through the book and demonstrate to you how to do these commands and provide some sort of context about why you would want to do them. So the data we're going to actually use is the GSS. And the first thing we're going to look at is a nominal level variable. We're going to go ahead and look at Zodiac. So we just want to type in tab Zodiac, analytic weight equals WTSS. And that'll give us a tabular form of data for us to actually look at. So the correct measure of central tendency for a nominal level variable is always mode. Mode simply being the most occurring data point within that question. There are two ways to sort of find it on this chart. The first is to look at the frequency. Simply choose the one that occurs the largest. You can see Cancer occurs the largest at 267, with the closest next being Virgo. So Cancer would be the correct answer. Another way to actually find that data is to look at the percent. So we know that of respondents, 9.63% were Cancer, whereas 9.45% were Virgo. So we know that Cancer is the mode of the data. And it occurs more frequently than any other. And when you're naming something that doesn't have distance, median, the most central point of the data, and mean, the average of the data, they don't really mean anything when the data doesn't have distance. When your variable has no distance, those things don't mean anything. So the correct answer for a nominal level variable is mode, which you can find by either looking at the frequency, the most occurring frequency, or the highest percent. Now, you also might want to actually graphically sort of represent this data. And there are two ways to do that the book shows you, and I'm going to go through both of them just to provide you with some examples. So the first one is simply graph bar. Make sure you have your analytic weight. And then we're going to do over Zodiac. So make us a bar over Zodiac. And that's all fine and good. It actually represents the data very well, but there are some issues with it. Primarily, you can't read the y-axis. The y-axis is intangible there. We know it starts with Aries and ends with Pisces, and then there's some stuff in the middle. But we can actually change that, and we can change that by opening up what is known as the graph editor. We simply open it up right here, and we click on this region, double-click it, go to Label Properties, and then select the angle to be 45 degrees. Now, as you can see, we can actually read the data set. We actually know what each is. And if we were simply looking to identify the mode, we would know that Cancer with the highest bar is the mode. Another thing that you can actually do with this data set, which I really like, is sort of eliminate this ugly bluish background. You simply go here to where color is and choose white, and you have a nice white background. In the future, you'll actually be asked to give these graphs titles, and the way you do that in the editor is simply type zodiac signs, and bam, you get a title. It says zodiac signs. So this is one way to actually do this data. When you're actually doing the homework, if you do it this way, you'll simply want to go over to File, Save As, provide it some name, zodiac signs. I would advise using this menu and pull it down and choose a high quality JPEG, save it as that, and that way you can embed it directly into your homework, which you're submitting via Word files. I'm not going to save this because I don't need it, but that's how you'd go about and do it. So I'm going to close this, it'll pop up, don't save it, and we move on. So there's another way we can actually generate the same exact graph, but with a little bit of command line operation. So first step we're going to do is we're going to hit this button right here. It's the do file editor. We're going to open up the dual file. I'm going to use exactly the same command in the book, but I'm going to go through and explain to you what it does. So I already have the command written out, so I'm just going to copy and paste it. But we'll go over in some detail what this is. I actually want to make sure you can read this. So now I have to figure out how to change the font, so bear with me. I will simply zoom in. There, now you should be able to read it. So we're going to do it. The beginning of the command is exactly the same. So graph bar analytic weight over zodiac. Now, in our last command, we simply ended with a parentheses right where my cursor is, but we're going to continue onward. We said we put a comma, and we say that for the label, we want to have the angle at 45 degrees, and we want to have the label size as small. Plus, as we did in the other graph, we're going to make the graph region white, so it isn't that ugly blue. Now, once you type this all out, and I'll give you a one bit of guidance, when you're typing out a command line like this, you want to make sure that your parentheses balance. So for every time that you open a parentheses, you want to make sure you close a parentheses. With unbalanced parentheses, the command will actually fail. And it won't provide you with too much instruction in terms of how to correct that. So without being able to stand over your shoulder in this environment, my best advice to you is look at the parentheses and make sure they're balanced, because that's really going to be where you run into the problems. To sort of get this graph put out, you simply highlight the region and hit this button right here, which simply, it's a play button, hit play, and it'll pop up your graph. And your graph will look, as you notice, exactly like the one that we did through the graph editor. And it's the same graph. So that's how you would generate a graph for a nominal level variable, generate a bar graph. And as you can see, the most occurring data point is Cancer, which is exactly what we found when we were looking at the actual tabular form of the data. So I'm going to close out of this. I'm going to close the do file editor. I don't need to save it. And now we're going to actually look at an ordinal level variable. See, for an ordinal level variable, we need to take into account that there is ordering, and therefore the mode probably isn't the most accurate accurate way by which to assess that data. For an ordered variable, so it has meaning going up or down in terms of size, what we need to focus on is the median, which is the 50th percentile point of the data. And we need to look at that using in terms of the graph. So we're going to go look at this variable called help for, just like your book did. And remember to do analytic weight equals WTSS. We're going to pop this up. So what we want to do is identify what the 50th percentile point of this data is. So where, if we were to take all 100 or all 1,887 respondents, who would be exactly in the middle? What data point would be exactly in the center? To do that, we're going to look at the cumulative selection of the data, the cumulative percent of the data. So 18% of the data, as you can see, these two overlap. So 18% of the data lies within this government action section. Now, the way you read this is in the second point, 14% of the data lies here, but the cumulative amount of that percent, that is this 18 plus 14, is right here, it's 32. So 32% of the data is covered in both of these two lines. Now, if you come down here, 75% of the data is included in these three lines. So if this line included 32% and this line includes 75%, then the 50th percentile point is located here, because this only accounts for 32%. This accounts for 75%, and since they're ordered, we know that everything from 32.27 to 75.14 is in this section. And so this would be your median, which is agree with both. So your median would be the numeric value of 3. That would be the median. And if you wanted to look at this graphically, you would use the same command. You would use the bar chart command, because it's going to provide you with the means to actually display this graphically. Any sort of ordered variable with not a lot of categories works really well as a bar chart. So since this variable is ordered, you're going to use median. Since the zodiac variable was nominal, therefore not ordered, you're going to use mode. Moving on to interval level variables, there's a lot more stuff that we can do with interval level variables. So we're going to spend the vast majority of our time here with interval level variables. We're going to use the same example that the book did, because it's really good. Now, let me warn you about doing this. we know age is an interval level variable. We know that the differences between each category are years. So the interval matters. The ordering matters, and the difference between the ordering makes sense. It's a quantity we understand. But when you type tab, it's going to spit out everything from 18 to 89 and older. Now, first off, this isn't a true interval level variable, but we're going to act like it is. The reason why it isn't a true interval level variable is because 89 or older could be 89 to 120. All individuals would be in that category. So everything below it is a difference of a year. This is a difference of a lot more than that. But we're just going to treat this as an interval level variable for all intents and purposes for our analysis. Now, a couple things. We can identify the mean and median of this data. Or not the mean, the median. We can identify the mean, median, and mode of this data. So the mode would be pretty easy to identify. We'd simply look down percent to see which one occurs most often. So 25, it's 2.05, 2.04, 2.22, so that one's more. 2.40. I bet that's it. Yeah, so wherever 2.40 was. Right here. So 57 would be the mode of our data. It's not very accurate, but it occurs most often. Now we could find the median. So as we see here, 48% of our data is included here. 50% is included here. So our median would actually be 47 because it'll include the 50th percentile point of the data. Now, neither of those are too super accurate. And what this command, the simple tabulate command, doesn't provide us is with the mean. And that's really what, more often than not, for interval level variables, we're actually interested in. We're interested in what the mean value is. Now, the way you actually get the mean value in STATA is not all that difficult. We're simply going to sum age. We're going to give it an analytic weight equal to WTSS. And this is the command. Now, so we can see we have a mean, 47, and we have the standard deviation. This provides us the range, total number of observations. But it doesn't give us all of the stuff we want. If we want to look at all the stuff we want, then we need to add one little thing. We need to put comma D. Now, what does this D stand for? It stands for detail. You could use the entire detail command, and I'll pop this out. Or you simply use D, and it's the same thing. So we just use comma D. This is simply more information provided to us about this variable. Now you can see the mean is right here. It's 47.56 on and on and on. And it also provides this thing called the standard deviation. Now we're going to talk a little bit about the standard deviation. The standard deviation is a measure of how central the data is. So if the mean is a measure of the average of the data, the standard deviation tells us how tightly grouped that data is around the mean. A small standard deviation means the data is very tightly packed. A larger standard deviation means that there's more spread within the data. So how do we calculate that standard deviation? Here's how. So there are a few steps to calculating the standard deviation. First, you figure out the mean, and you figure out the deviations from the mean. So we know the mean here on this example is 58. This is fake data, but it just provides us with an easy way to understand it. You find the mean and the deviation from the mean, and you calculate each individual deviation for the mean for every respondent. So you can see why in this reality we actually only have 11 respondents, because it just makes it easier. And then from calculating each individual level deviation from the mean, you then square that deviation. The reason why we square it should be pretty obvious. We're trying to get rid of negatives. And since we're trying to measure the centrality of the data, not necessarily left or right, the squaring sort of makes sense. After you square these deviations, you divide that square by n minus 1 to find the variance. So here you go. The variance is equal to the sum of the squares divided by n minus 1, n being the number of cases. So we have 11, minus 1 is 10. That'll give us the variance. We square the variance to come up with the standard deviation, which in this case is 26.2. Now, what does this 26.2 tell us? It tells us a few things. Primary to our interest, this standard deviation tells us that 68% of the data falls within plus or minus the mean plus or minus 26. So it's 68% of the data falls in that area. Back to this example, it tells us that from the mean, 68% of our data falls within 47 plus 17. So the data is fairly tightly packed. So that standard deviation provides us a nice way of describing how central the data is. If there was a larger standard deviation, it would be there'd be more deviance from that mean, from that central point. Now the next thing we want to look at is this idea of skewness. So skewness describes also the centrality of data, but also the direction of the skewness. So skewness generally below 1 is not too problematic. Now what skewness is trying to tell us is whether we should use median as the measure of central tendency. In this case, below 1, it's basically telling us go ahead and use the mean. The mean is fine. But what a highly skewed data set will cause you is it will also affect the mean. So if you have a lot of negative outliers, or if you have a lot of low outliers, or you have a lot of positive outliers, it will pull the mean in that direction, either left or right. Skewness is basically telling us how much the mean is pulled by these outside data points. In this case, it's telling us it's pulling very little. The data is pretty centralized, and there's not a big, what we would consider a left side tail of the distribution or right side tail of the distribution. So that provides us with, at the very minimum, a way of judging how skewed the data is. Another way of looking how skewed the data is to simply do a histogram. So the command for histogram is simply histogram age. Make sure we have to change from an analytic weight to a frequency weight. So the frequency weight equals WTSS underscore. Oh, I didn't do it, so I have to generate it. You'll also have to do this too. So generate WTSS underscore RND is equal to integer WTSS. Hooray. Now we can scroll back up and histogram, age, frequency weight is equal to WTSS underscore RND. And we want it to be in percent. So that is not great. There's a lot going on there, and it doesn't provide us with a lot of guidance. It tells us the general shape of the data, but the binning, so each of these columns is considered a bin, the binning doesn't line up neatly. So what's one way to change that? Well, we start the graph editor, and we change the tick properties. So you can change the ticks here. You can change the min and max. You can change the range and delta. So here we're going to, let's say minimum value of 20, maximum value of 90, and then 10. So the difference is every 10 points. And that makes it look a little better, but not great. Other way to do this, the way I often prefer, the way I advise you to do is, again, open your do file. And we'll go through and at some length. So again, the beginning of the command is the same. Change the colors, that's really not that important, but here's the width. So the width between each data tick is 5. So the distance of each column is 5, and we're going to start at 20, and the labels are going to go up every 10. So what is this going to look like? How is this going to improve the graph? There you go. It makes it just a little bit better. We can see more of the curve. We can see the nature of it. It also stops. It doesn't go on. But this is a histogram. And as you can see there, this is what we would consider a right-hand tail, but it's not too long. So this portion right here, so from 60 onward, that's a right side tail. That's why your skewness is positive. But it's also very small, as this doesn't account for a large amount of the data. A large amount of the data is right within, remember that the mean here is 47. A large amount of data is right here in the center. And what that means is that this skew isn't pulling the mean too far off of what a good measure of central tendency would. If, let's take for example, this was the highest point of the data. So the bin for this 20 section would be the highest point of the data, and it just went down. Well, then you would have a long right side tail, and that skewness measure would be significantly higher. And what it would be telling you is that the median, the 50th percentile point of the data, is actually a better representation of central tendency for that variable as opposed to mean. But in this case, for this age variable, the mean is a perfectly good representation of a measure of central tendency. So in terms of the homework for this week, this is all you need to know. This is the entirety of the commands you'll be using. The book will provide you a significant amount of guidance, and I replicated the book so you could see what it actually looks like when you're doing it. Any questions, stick them in the forum, but as I've advised you, and now's a good time to get used to doing it, you should really be doing this homework in groups through Blackboard, because when you come upon problems, and there will be problems, you saw me make some mistakes as I was typing out commands, having people there to help, even your classmates, is significantly better than trying to do it by yourself and getting frustrated. So I want you all to try to do the first week of homework this week. I know I said the homework is due on Sunday. It's not due on Sunday. You can take as much time as you need to do it. But for the first one, I would like you all to try to get it done by Sunday, because it will give me an idea of how well you all are using the software and what sort of problems are coming up. And therefore, I can sort of change or modify or do new stuff going into next week when we start to do a little bit more complicated things with the software. Have a good week.